Today we will discuss the numerical problem on forced damped vibration, in which we discuss a numerical, that is a body of mass m, that is 70 kg, is suspended from a spring which deflects 20 centimeter. Deflects means the amplitude of the spring is 20 centimeter under the load. It is subjected to a damping effect adjusted to a value of 0.23 times that required for critical damping. Find the natural frequency of the undamped and damped vibration and ratio of successive amplitudes for damped vibration. If the body is subjected to a periodic disturbing force of 700 Newton and of frequency equal to 0.78 times the natural undamped frequency, that is the frequency is 0.78 times of the natural undamped frequency, find the amplitude of forced vibrations and the phase difference with respect to the disturbing force, in which we have to find natural frequency, amplitude, and the phase difference, that is the phase angle. To determine the natural frequency, we should have the value of omega n. For omega n, we should have k and m, because omega n is equal to root k by m. For finding the value of k, we know that in case of spring, that is the force, spring force is equal to kx, from where k is equal to F by x, F that is force and x is the deflection. The value of force that is 700 into 9.81, and the deflection that is equal to 20 centimeter. If we convert in the meter, then the value of k we will find 34.335 into 10 to the power 3 Newton per meter. Now we have to find omega n. Omega n is equal to root k by m. By putting the value of k, that is 34.335 into 10 to the power 3 Newton per meter, and the mass is 70. If we solve this, then we get the value of omega n is equal to 22.15 radian per second. And in the question, in which the value of zeta, that is the damping factor, is given is equal to 0.23 or zeta is equal to c by cc is equal to 0.23. Next we have to find damped frequency. We know that damped frequency omega d is equal to in root 1 minus zeta square into omega n. By putting the value of zeta and omega n, we have already find the value of omega n is equal to 2.15 radian per second, and the value of zeta is equal to 0.23. Then we will get the value of omega d is equal to 21.57 radian per second. And next we have to find logarithmic decrement. The question says that we have to find the amplitude ratio, that is the ratio of successive amplitude for the damped vibration. Then the logarithmic value of amplitude, successive amplitude, means xa by xb. We know that from the formula, that is 2 pi zeta upon in root 1 minus zeta square. By putting this value, we find the logarithmic decrement, that is 1.48. But we have to find the successive amplitude, means xa by xb. Then log is transferred in the form of e. Then the value of xa by xb, that is e to the power 1.48, that is equal to 4.39. If you find the value of amplitude, then we have the formula of force, that is equal to ak in root 1 minus omega by omega n square, that is whole square, plus 2 zeta omega by omega n whole square. This is the formula of force. Here we have to find the value of amplitude, that is f by k upon in root 1 minus omega by omega n square, that whole square, plus 2 zeta omega by omega n whole square. We have the value of force, that is 700 Newton, and the value of k is equal to 34.335 into 10 to the power 3 Newton per meter. And the ratio of omega by omega n is 0.78. If we put the value of fk and omega by omega n in the equation of amplitude, then we get the value of amplitude is equal to 0.038 meter. That is the final value of amplitude. And then we have to find the formula. Next we have to find phase angle by the formula of n phi is equal to 2 pi 2 zeta omega by omega n 1 minus omega by omega n whole square. We have the value of zeta is equal to 2.23 and omega by omega n is equal to 0.78. By putting this value in this formula, then we get the value of n phi is equal to 0.916. We have to find only phi phase angle, that is equal to tan inverse 0.916, that is equal to the 42 degree and 29 minutes. That is our final answer. Thank you.